challenge, and today we are going to solve our next problem statement, leaf similar trees. So let's start. Consider all the leaves of a binary tree from left to right order. The value of those leaves form a leaf value sequence. For example, in the given tree above, the leaf value sequence is 6, 7, 4, 9, 8. Two binary trees are considered leaf similar if their leaf value sequence is the same. Return true if and only if the two given trees with the head node root 1 and root 2 are leaf similar. So we have given a two binary tree, we need to find out if it is a leaf similar or not. So first we need to find the leaf sequence of the root tree, and we need to know what is leaf. So leaf is the node where it do not have a left subchild and the right subchild also. So for this binary tree, 6, 7, 4, 9, 8 is the leaf node because it do not have the left subtree and also the right subtree. And we need to make a sequence from left side. So 6 is on the leftmost side, and you need to make a sequence of all the leaf nodes. So you start from the 6, 7 come next to the 6. So 6, 7, 4, 9, 8. So this is the sequence. And we need to, and similar operation we need to do for the another tree also, and we need to find out if the array, that is the leaf sequence array, is equal or not. So we have given these two binary tree, and the leaf sequence for this binary tree is 6, 7, 4, 9, 8. These are all the leaf node here, and this is the sequence. For this also, the 6, 7, 4, 9, 8 is the sequence. So both the sequence are correct. So the output is true. It is a leaf similar tree. Similarly, sequence is not correct. You can argue like 2 and 3 is equal to 3 and 2, but a sequence is not correct. The sequence would also be same. So you should count it from the left to right side, make an array, and that array should be equal, and the ordering should also be equal. So let's try to solve this problem statement. To solve this problem statement, we need to do a DFS traversal for this tree and count all the leaf tree sequence and count all the leaf node and make a sequence. A similar we will do for another binary tree, and we will check in the end if both the sequence are equal or not. So first we need to write a traversal logic. So make a method traversal and pass a node, tree node. We are taking a array list to store all the leaf node value. So this is our leaf node array. Then if our, let's say it is a head, you can say root. But if our root is null, we do not need to travel forward to return it. If we know that any node is a leaf node, it means it should not have any left and right subtree. So if our left subtree for the root is not there, and also the right subtree is not there for the root, we say it is a leaf node, so we add it in our leaf node array. Add it in your leaf node array. So we added a value of the root and we return it. Now we do not need to do further processing. Then if it is not a leaf node, we need to travel first left and then right. So we are doing the DFS traversal. So call the travel method recursively, pass the left subtree and your leaf node value, leaf node array. And similarly, travels to the right subtree path. Root.right, leaf node value. We have done the DFS traversal, and if it is a leaf node, we are adding it in the leaf node array, and then we are traversing left to and then the right side. So our expectation is, if we are passing an array, so first we will travel it for the one binary tree and we'll find out all the leaf node sequence. Then we will pass the another binary tree and we'll find out the leaf node sequence, and then we can basically check if both the sequence are equal or not. So create your two array integer I am saying left binary tree or right binary tree. So left binary tree sequence. Similarly, list of integer and right binary tree sequence. Have a list. Now do the traversing for for the first binary tree. Instead of calling left binary tree, we can also call it root 1 because they have path root 1 and root 2. But I think that it will not create a confusion for us. So root 1 sequence or root 2 sequence. I think now it is fine. So root 1 sequence. A similar travel for the root 2 also. Now we have traveled to both the binary tree and created our sequence. Now we need to check if both the array is equal or not and their sequence and all the elements are same. So we can use Java equals method, or you can do by the for loop also. But there is an inbuilt function equals that you can use. So root 2 dot root 1 dot root 2. If both the array are equal, return true, else return false. So this is done. And now we can run our test case. We have some error. Leave node. Okay, leave node dot add. So our one test case is working and one is failing. So let's see why. So we are traversing from left to right. We are returning to dot right. We are getting our 2 sequence. Into 1 equals to 2 is true. We can check our both sequence, if it is equal or not. The root 1 sequence. Similarly, you can copy paste with that. Root 2 sequence. For sequence is equal. Okay, so why it is not working? Root 1 dot equals root 2. So good false and 2, similarly 1, 2, 3 and 2 is not equal false. Root 2. Okay, I have added root 1. It is a root 1 sequence actually. That's why it is not working. Root 1 dot root 2 sequence. Yeah, now let's run the test case. Yeah, so now it is working. And now let's submit a solution. So our solution is also working. And yeah, thanks for joining the session. Let's meet tomorrow.